All right, what is up? We're going to go over some of these examples for just how to set up projectile problems, because now, not so much with these ones where they're dropped, but as these problems get a little bit more complicated, you have two directions now to worry about. Something is a projectile when it only has the force of gravity acting on it, and it has x direction and y direction now to worry about. So one of the first things we want to do that you see here is this little table. And I included tables for you guys to fill out in the beginning, and then as the practices go on, you'll start making your own tables. But yeah, it's just a way to keep track of all of our values that we have throughout a problem. And it helps just organize everything, okay? So going through this, first example problem, an object is dropped. A ball is dropped from a bridge that is 500 meters above the water. Okay, best way to get an understanding of what's going on, draw it. So we got a bridge, right? Person's up here, and down here, real far, some water. That water is 500 meters below. That's about it. That's all we know. Okay, so the thing is with these problems, there's a lot of info we can get just through context. So displacement. Okay, let's figure out displacement yet. First of all, if I just drop something, right? If I just drop it straight down, a couple things I know is its initial y velocity is 0. Okay, so initial y velocity 0 meters per second. Displacement. Well, this thing has to fall 500 meters down. And that's where we got to be careful. If this down here is 0, if this is 0 height and this is 500 up here, it's falling down 500 meters. Right? If I go to do displacement, and that's final position minus initial position, well, its final position is 0. Its initial position is 500. So that negative 500 is telling us it finishes 500 meters below where it started. Okay? So negative 500 meters for displacement. And that's about all the pieces that it gives me. And then there's a couple other things I always know about projectiles, right? If something is falling and only the force of gravity is acting on it, that tells me the acceleration is going to be negative 10. So I have a negative 10 acceleration in the y, and in the x direction, I'm always going to have a 0 acceleration. And time, we don't know yet, and that's about it. Okay, but notice right here, I got 1, 2, 3 pieces of information. With all of our old kinematic stuff, if I know 3 pieces of information, then I have enough to solve for the fourth one. Okay, so when we set this up, we know how long until the ball reaches the water. So we're solving for time. So we need something that has time, displacement, initial velocity, and acceleration. That is our equation that looks like so. And remember, first step, make your life easy. If we have 0 anything, let's use that to our advantage to make the equation a little nicer. So 0 initial velocity, that means this whole chunk is going away. All right, so we have displacement is equal to 1/2 at squared. And we are being asked to solve for time, so I'm going to solve for t first. We'll do it the long way because we're not in a hurry here. If I solve for t, I'm going to multiply by 2 on both sides. So multiply by 2 over here, 2 over 1 to get rid of that 1/2, which means I need to multiply by 2 over 1 on the left side. And we end up with 2 times displacement is equal to at squared. So now I divide both sides by a. And almost running out of room. I got t squared is equal to 2 times the displacement over the acceleration. And then the last step would be to square root both sides. Okay, so I'm going to square root both sides right there to give me, and let's just kind of continue it up over here. I got time is equal to the square root of 2 times the displacement divided by acceleration. And when we plug in our numbers, let's see what we get. 2 times negative 500 over negative 10. So that's 1,000 on top divided by 10. The square root of 100 is a time of 10 seconds. So it's going to take 10 seconds for that thing to fall 500 meters down to the water. All right. How fast will the ball be going when it reaches the water? So now that we know time, right, I'm going to go back to my table and I'm actually going to put that value in there. I know this is 10 seconds, which time is the only thing that can be shared in both columns. So also 10 seconds in the x direction. And if I know time now and I want to know final velocity, I got my pick of any of the equations that I want to use to find final velocity. So I'm going to look at my kinematic equations and pick probably the easiest equation to use for that is right here. Okay, and this is all in the, we're dealing in the y direction right now. There's no, the ball's just falling straight down. There's no x velocity involved, so just y. All right, so I'm only going to use numbers from this y column. Okay, and from there, let me scoot that up a little bit. And I plug it in. Final velocity in the y is it's negative 10 acceleration for 10 seconds. And it started with a 0 y velocity. So my final velocity is going negative 100 meters per second. And that makes sense. Think about it, if something accelerates 10 meters per second every second, and then it's falling for 10 seconds, it's going to be going 10 times 10, 100 meters per second, down. That's what that negative means. It's falling down. All right. Part C, what are the x and y components of velocity just before it hits the water? Well, if this was our ball, so the person drops the ball and then it starts falling and it goes further and further. By the time it gets down here close to the water about to hit, we would have only a downward velocity arrow of 100 meters per second going down, and it was not going sideways at all, so there's no x component. Right? Really, if we wanted to make this a legit motion map, we'd have to have 10 little dots because it's 10 seconds of flight. But yeah, there's just one y component right now because there's only movement in the y direction. So that's what our x and y components would look like. Okay. Let's take a look at the next example. A ball is thrown straight up with an initial velocity of 30 meters per second. So again, this is all y direction stuff. I don't know anything about displacement yet, but I know the initial y velocity is positive 13 meters per second, right? Somebody is, let's see. Somebody's throwing a ball up, right? And it's on its way up. So, yeah, throwing the ball up and it leaves the hand at 30 meters per second. And what else do we know? We always know acceleration, right? There is 0 acceleration in the x direction, and there is always the acceleration from gravity, negative 10, in the y direction. Let's see, a ball is thrown. Okay. That's about all we know. So part A, how many seconds does it take for the ball to reach its highest point? Okay, so highest point gives me something that I know. At its highest point, that's the very top of that parabola, right? What is its y velocity at the very top of the parabola? 0, right? At the very top, it stops for a second before it starts falling back down. So I also know from this that its final velocity is going to be 0 when it's at the very top. So now I have my little set of conditions. I know 3 things. Okay, that's my indicator that I have enough to solve for whatever it's asking for, and it's asking me for time. So first, reason through this. It is accelerating at negative 10 meters per second every second. Okay? It starts going up 30. 1 second later, how fast is it going to be going? 20. And then 10. And then 0. So overall, from starting at positive 30 meters per second, if it's slowing down by 10, it's going to should take 3 seconds to get there. Okay? So if these are all of the, let's get my little highlighter thing. All right, if this is all the values that I know, let's see what we can solve for. Pick a kinematic equation that has all those. That would be what we left off the last example with. Okay, we're trying to solve for time, so I would subtract V naught from both sides. V minus V naught is equal to AT. And then again, I'm trying to solve for time, so I'm going to divide both sides by T. Those guys, wait, that was dumb. No, I'm trying to solve for T, so I'm going to divide both sides by A. There we go. All right. So from there, we solve. I got T is equal to the change in velocities over the acceleration. Well, final velocity is 0. Initial velocity was positive 30. And the acceleration is negative 10. So that's negative 30 over 10, negative 10, which gives us 3 seconds. Boom. So our reasoning and our math agreed, so that's always a good sign. Okay. How fast is the ball going when it returns to the thrower's hand? Another really good question for conceptual stuff, because what do we know about the shape of when we throw stuff up in the air as a projectile? Right? It makes a parabola. Okay? And the beautiful thing about parabolas, they are perfectly symmetrical. So however long it takes to go from the bottom up to the top, it's going to take that same amount of time. Let's say that takes time t. It's going to take that same amount of time to go from the top to the bottom, right? Also, let's get those out of there. Speed is the exact same thing. However fast it leaves the person's hand going up, it's going to have that same exact speed going down when it comes to the other side. Okay? So what do we know? We know this thing started out going up at positive 30 meters per second. So because we know parabolas are symmetrical, when it comes back down to that exact same height over here, it's going to have the same speed going down. So its velocity would be negative 30 meters per second in the y direction. Okay? Now obviously, I drew this kind of weird because the ball is just going straight up and down, But that would still be, it's like a really skinny parabola. Right? It's like a parabola that doesn't go anywhere. So it just looked like it goes straight up and down on top of each other. But we can draw like a normal parabola just to kind of see what's going on. But yeah. So we can do it that way. If we wanted to solve this with math, we know it takes 3 seconds to get up to the top, which means it's going to take 6 seconds to go all the way to the top and then back down. So what you can do is just solve this with our kinematic equations. Right? We want to know the final velocity. We know the acceleration is -10. We know the time now is a total of 6 seconds to get back to the person's hand, and it started at positive 30 meters per second. So you punch that into a calculator, do a little math. That is -30 meters per second. Boom. Everything agrees. We're happy. All right. And yeah. So you can reason your way through a lot of these, and we should be good to go. All right. I will see you guys later. Send me an email or note or anything like that if you guys have questions, and I will catch you on the flip side.